Imagine a quiet night, the sky a velvet canvas studded with stars. You lie back, gazing at the Milky Way's shimmering arc. The numbers are staggering. Our galaxy alone contains over 200 billion stars, many with planets orbiting them. In the observable universe, there are at least 2 trillion galaxies. With so many worlds, so much time, and the sheer statistical likelihood of life emerging, why is there no sign of intelligent beings? This is the Fermi Paradox, the dissonance between the high probability of extraterrestrial civilizations and the utter silence of the cosmos. Enrico Fermi, the physicist who first posed the question, famously asked, "Where is everybody?" The paradox is named after him, but its implications reverberate far beyond astrophysics. It is a question that probes the very essence of humanity's place in the universe. Are we alone? Or is something darker, something unimaginable, preventing us from knowing? The paradox is unsettling not just because it challenges our cosmic loneliness, but because it hints at existential risks. If the universe is teeming with life, why have we not detected radio signals, starships, or even the faintest trace of an alien monument? The answers we consider, whether optimistic or grim, force us to confront the fragility of our own existence. The Fermi paradox hinges on the Drake equation, a formula proposed by astronomer Frank Drake in 1961 to estimate the number of detectable extraterrestrial civilizations in our galaxy. The equation multiplies several variables. 1. The rate of star formation in the Milky Way. 2. The fraction of stars with planets. 3. The average number of habitable planets per star. 4. The fraction of those planets where life emerges. 5. The fraction of life-bearing planets where intelligence evolves. 6. The fraction of intelligent civilizations that develop detectable technology. 7. The length of time such civilizations remain detectable. Even conservative estimates suggest millions of civilizations could exist. For example, if only 0.1% of stars have a habitable planet, and 1% of those develop intelligent life, the Milky Way alone could host 100,000 civilizations. Yet, as of 2023, we have found no conclusive evidence of any. This discrepancy is the heart of the Fermi paradox. Possible explanations fall into 2 categories. They are there, but we cannot detect them, or they are not there for reasons we cannot fathom. 1. The Great Filter. Proposed by economist Robin Hanson, the Great Filter is a barrier that prevents life from reaching interstellar communication. It could be at any stage of evolution. Abiogenesis. The leap from non-life to life might be extraordinarily rare. Simple to complex life. Perhaps most life remains microbial, never evolving into multicellular organisms. Intelligence. Intelligence might be a fluke, as seen in Earth's history, where complex life took billions of years to arise. Technology. Even if intelligent, civilizations might destroy themselves, e.g., nuclear war, climate collapse, before sending signals. Sustainability. Maybe civilizations inevitably outgrow their planets, leading to self-destruction. If the Great Filter is behind us, say intelligence is rare, then humanity might be special. If it's ahead of us, we could face extinction. 2. The zoo hypothesis. Advanced civilizations might avoid contact to let us evolve naturally, much like humans observe wildlife in reserves. This raises ethical questions. Are we being watched, or are we truly alone? 3. Self-destruction. Civilizations might destroy themselves through war, environmental collapse, or AI takeover. If so, the galaxy is a graveyard of extinct species. 4. The rare Earth hypothesis. Earth's conditions, its stable climate, magnetic field, and moon might be uniquely suited for life. Intelligence could be a cosmic rarity. 5. They're here, but we don't recognize it. Maybe aliens exist in forms we cannot perceive, or their technology is undetectable. For instance, quantum communication or interdimensional travel might leave no trace. 6. The universe is young. Perhaps we're among the first intelligent species. If the cosmos is 13.8 billion years old, but life took billions of years to evolve, civilizations might just now be emerging. Exploration of implications. The Fermi paradox is not just a scientific puzzle, but a mirror reflecting humanity's fears and aspirations. 1. The existential threat of the Great Filter. If the Great Filter is ahead of us, humanity faces a grim future. The list of potential catastrophes is long: nuclear war, climate collapse, pandemics, AI superintelligence, or cosmic disasters like gamma-ray bursts. The paradox suggests that every previous civilization might have succumbed to one of these. Consider the doomsday argument, which posits that if most civilizations die young, we are likely among them. This is a statistical weight. If intelligence is common, we should have encountered others by now. Since we haven't, we might be among the first or the last. 2. The ethics of cosmic loneliness. If we are alone, it could be a source of existential dread or a call to responsibility. We might be the first to explore the galaxy or the last survivors of a dead universe. This duality shapes our sense of purpose. Are we custodians of life, or are we doomed to repeat the mistakes of unseen predecessors? 3. The paradox of silence. Why would advanced civilizations hide? The dark forest hypothesis, from Lutzeschin's The Three-Body Problem, suggests that silence is survival. Civilizations remain silent to avoid attracting hostile aliens. Broadcasting our existence could invite annihilation. 4. The illusion of progress. The paradox humbles human arrogance. We pride ourselves on technological advancement, but if we are the first, our achievements are still minuscule in cosmic terms. Conversely, if we are latecomers, we might be on a path to extinction. 5. The search for meaning. The Fermi paradox forces us to ask, what is the point of life if we are alone? Or conversely, what if we are not alone, but our ignorance is the point? The paradox is a philosophical quandary about purpose and existence itself. 6. The role of time and scale. The universe is 13.8 billion years old, but radio signals travel at light speed. Even if a civilization is 1,000 light years away, its signals would take millennia to reach us. We might be in a cosmic quiet zone, where civilizations are too far apart or too short-lived to intersect. 7. The simulation hypothesis. If we are alone, perhaps the universe is artificial. The simulation hypothesis, explored in segment 5, suggests that our reality is a programmed construct, and other civilizations never existed. This ties the Fermi paradox to the idea that we might be alone because we're in a simulation. 8. The paradox of probability. The Drake equation's variables are guesses. Even small errors in estimating the likelihood of life or intelligence could drastically alter the results. Maybe we've overestimated the chances of alien contact or underestimated the challenges of interstellar communication. 9. The cultural impact. The paradox has shaped science fiction from Contact to Arrival, where humanity grapples with the implications of first contact or its absence. It also fuels projects like SETI, Search for Extraterrestrial Intelligence, which scans the cosmos for signals. 10. The comfort of mystery. The Fermi paradox reminds us that the universe is vast and mysterious. Even if we are alone, our existence is a miracle. The paradox is a reminder to cherish our planet and seek answers without arrogance. The Fermi paradox asks, why is the universe so quiet? The simulation hypothesis suggests an even more unsettling answer. Maybe the silence is because there is no one else. After all, we're all just code in a cosmic experiment. Imagine a universe where every star, every planet, and every living being is a simulation. The Fermi paradox's silence is not a mystery, but a design choice. There are no aliens because there are no real aliens, only us, existing within a programmer's framework. This is the simulation hypothesis, the idea that reality is a digital construct akin to a video game or a supercomputer simulation. It turns the Fermi paradox on its head. If we are in a simulation, the absence of aliens might be intentional, or perhaps we are the only players in this cosmic game. The simulation hypothesis is not just philosophy. It has roots in physics and computer science. Physicist Nick Bostrom's 2003 paper argued that advanced civilizations might simulate countless ancestral worlds. If so, the odds of us being in base reality are infinitesimal. As we turn to the simulation hypothesis, we shift from the silence of the cosmos to the silence of the programmer. The Fermi Paradox asks, why are we alone? The simulation hypothesis whispers, we are not alone, we are the experiment. This expansion weaves the Fermi Paradox into a meditation on humanity's place in the universe, existential risks, and the nature of reality. It avoids bullet points by using narrative and philosophical exploration, maintaining the reflective tone. The transition bridges seamlessly to the simulation hypothesis by suggesting that cosmic loneliness might stem from artificiality rather than chance.